Hello, ladies and gentlemen. Root Beer here, and we're going to continue our look at the 2013 Open Contest. This time we're up to question C2. So, still a question. We have to explain everything. We got three parts here to C2, and what have we got going on? A. Determine all real solutions to a squared plus 10 plus is equal to a plus 10 squared. So some nice symmetry here, and we might be able to exploit that, but of course this is just a quadratic, so we could instead just rearrange that. So bring everything over to the one side. 10 minus 100 will be 90. And so we could factor this. Maybe, oh no, it'll be negative 90. Two numbers that multiply to negative 90 and add to negative 1. Factors of 9 and 10 differ by 1. And I need it to be negative 1 for the sum, so there we go. Nice. So A could be negative 9 or 10. We'd expect two solutions there, just because this is really just a quadratic. This is a very nice sort of symmetric looking quadratic. Okay, B part. Determine two positive real numbers, A and B, both greater than 0, so that A and B are not equal, and A squared plus B is equal to B squared plus A. So again, the same sort of thing we had earlier. So A squared and then 10. So couldn't B be 10? But then A can't be 10, so A would have to be negative 9, so that doesn't quite work. Well, let's take a look at this. So A squared plus B is equal to A plus B squared. I guess we can do the same sort of rearrangement. But we'll have B minus B squared, and that's our constant term. Now, can this be factored like it was before? Because 10 was one of the solutions. And I'm willing to bet A equals B is a solution just because they're specifically trying to rule that out. So, can we do that? So if B was one of them, then we'd have 1 minus B. Could have A minus B. A plus B minus 1. Yeah, because then the B's would cancel out, and you'd be left with a minus 1, which is exactly what we need. Alternatively, if you didn't want to do that, you use the quadratic formula. But this means that either A is equal to B, or A is equal to 1 minus B. Okay, so we specifically... let's actually write a sentence, since... we don't want A equal to B. Not let's. Let's say we need A to be equal to 1 minus B. Now we've got A is greater than 0 and B is greater than 0. Now if A is greater than 0, that means 1 minus B is greater than 0. And so 1 is greater than B. So any B with 1 greater than B greater than 0 should do. I'd pick a half in the middle, but then A and B would be equal to each other again. You'd get a half. So, I don't know, let's B equal to 1/3, A equal to 2/3 suffices. That should work. They're both positive. And if we want to, we can double check it. A squared is 4 over 9 plus B, and then B squared is 1 over 9. So we should get 4 over 9 plus 3 over 9 is equal to 6 over 9 plus 1 over 9. And they are both 7 over 9. Okay, so that does work. Just a very quick little double check, just in case I'd made an arithmetic mistake or something anywhere. We don't want to be losing marks if we can help it. So, we're welcome to trust our reasoning and what we write down, but a very, very simple little check like that makes me think, okay, this is being nice, this is clean, this is working out. Okay, so that's B part, because we just wanted 1. determine 2 positive pairs. We just wanted 1 pair. Now C part. Find all triples of real numbers A, B, C. All triples. Okay. Such that A squared plus B squared plus C is... Okay, so again, this basically the same sort of thing. Nice little symmetry. We're just sort of rotating A, B, and C, their positions in this. Is equal to B squared plus C squared plus A is equal to C squared plus A squared plus B. So if we look... If we consider the equations pairwise, we see A squared plus B squared plus C has to be equal to B squared plus C squared plus A, but those cancel. So we get A squared plus C equals C squared plus A. And as we learned in B, A is either going to be C or A is 1 minus C. And we could do the same thing comparing A and B. So we could get C squared plus A squared plus B is equal to B squared plus C squared plus A. Now the C squareds don't matter. So A squared plus B, this is the one we just solved. So A is B, or A is 1 minus B. So these are potential relationships. Now we also technically yet, and so I'll just write it down here. I don't think we need it, because this relates A's and B's. Similarly, we also would get B equals C, or B is 1 minus C. Now, I have a bone to pick with the wording here, because they say find all triples. I don't like this word find, because we're not going to have sort of a list of triples that we can list out. It's going to be, I think, an infinite number of possibilities. I personally, as writing a contest, and I've written contest questions for, I would have said, write families or something like that. I'm not confident with find. I was going to suggest determine, but determine also makes it seem like it's fine. I just feel like that word's not good. Oh well, but I'm pretty sure, because they don't have any conditions. So, for example, A satisfies things. Or we could have C being 1 minus A. I guess we can rearrange this as C is 1 minus A, or B is 1 minus A. Just easier ways to rearrange it, and we're just going to get family. So we could have A, and 1 minus A. That should work, because then the B and the C satisfy this relationship here. Or what else could we have? We'll just keep the A as it is. We could have 1 minus A and A. We're gonna have A 1 minus A. Now here the B and the C would be equal, but they'd be different from the A unless A were a half. And they didn't say anything about positive integers, so I guess they want pairs or triples of real numbers. So I guess for all real numbers, A are the only solutions to the set of equations. There we go. Kind of short. I just double checked. Okay, so I'm just worried. C seemed kind of quick, so I'm worried that I've missed something. Just canceling out the equations. I didn't miss anything, did I? No, C squared plus A squared plus B is still an equation. Just reduces to the B case, and there were only 2 solutions to the quadratics, so I haven't missed a case, right? So once I pick an A, I've got 2 choices. Either the C is the same as A, or the C is different from A, and therefore it would have to be 1 minus A. And then the choice of B is independent. Once I choose an A, the B could be equal to A, or the B could be 1 minus A. And so we get these 4 cases. The only problem would be if one of them doesn't work out, but either the B and the C are equal to each other, or B is 1 minus C, which is those 2 cases. So this one and this one give us the ways to make B and C from A, and they just also happen to satisfy the third possibility. So I don't think we're missing anything. I think it's just a nice, clean, short C2. All right. So up next will be question, there it is, C3. So feel free to take a look at that. And as always, I will see you for more math in the next video. Until then, take care and have a wonderful day.